We, Dr. Bekmiri,
and Jumabaeva Arjan have found an innovative solution to the problem of oil pollution of the Caspian Sea, which can help billions of people. As a result of the project, an inexpensive, superhydrophobic polymer nanomaterial was developed.
according to statistics from Imisatasar, Kazakhstan has experienced 329 oil spills over the past 20 years, with a total contamination area of 1,000 square kilometers. This issue has not gone unnoticed by us. Since 2023, we have been exploring methods for oil removal from water, leveraging the potential of nanotechnology to significantly improve the quality of human life.
As a result of in-depth theoretical research, polystyrene polymer and graphene oxide processed from graphite ore were selected as the primary components of the membrane. After preparing the solution, an electrospinning device was used to create nanofibers. This process involved electrostatic repulsion, which stretched and induced chaotic movement in the flow, resulting in the formation of extremely fine fibers. A ready-made nanocomposite was obtained.
The initial analytical experiments were conducted using scanning and transmission electron microscopes. The studies revealed that the membrane possessed the capability to separate oil from water. To validate the data obtained from this analysis, a goniometer was employed. This instrument revealed that the contact angle of the membrane exceeded 150 degrees, demonstrated its capability to effectively address the problem in the Caspian Sea. To assess the mechanical strength of the fabricated membrane, a microsystem texture analyzer was employed.
The membrane was tested with water and cyclohexane to evaluate its efficiency and performance. When water came into contact with the membrane, it was clearly observed that the water did not pass through the nanocomposite and remained on its surface. In contrast, cyclohexane easily and rapidly passed through the membrane. Thus, the polymeric nanocomposite we developed proved to be an effective method for separating water and oil.
To elucidate how this membrane will facilitate removal of oil pollutants, following schematic is provided. Contaminated water will be pumped by the specialized water pumps, with the pressure in the pipes measured by a manometer. The fluid then travels through the pipes into the spiral membrane filter system, where it passes through spiral wound membranes. Then oil and water fraction are separated into different reservoirs. The recovered oil can be reutilized, while the purified water is returned to the sea.
In order for the drone to fulfill its functions, we have decided to use a combination of OpenCV and the standard Arduino platform. Firstly, the drone will use computer vision to locate the oil spill. After receiving the GPS coordinates of the spill, the boatbot will make its way there using its own Neo 6M GPS sensor. When it is near its destination at a distance of 1-3 meters, the boatbot will deploy the buoy boat, which will circle around the spill and leaving its buoys behind. Then, boatbot will begin absorbing the oil using a special pump.
Now we will talk about the numbers. First, let's look at material cost. The total cost for two membranes is just $1.87 or approximately 991.8 tenge. The most expensive components are dimethylformamide at $1.10 and graphene oxide at 76 cents. Meanwhile, polystyrene is incredibly cheap, less than 1 cent. When we add up all production costs, including materials, electrospinning, processing, labor, and electricity, the total cost per two membranes comes to just $2.89 or 1,530 tenge. This makes our technology not only affordable but also highly scalable for large-scale applications.
Let's compare our membrane with traditional methods. Activated carbon filtration costs between $50 to $100 per square meter. Ultrafiltration can go up to $200, and reverse osmosis can reach $400 per square meter. In contrast, our membrane costs just $11 per square meter, while achieving an outstanding 98% efficiency.
In conclusion, our membrane is not only cheaper to produce but also significantly reduces operational costs. Its low cost, high efficiency, eco-friendliness, and long lifespan make it the best solution for water purification.